Last question of this paper is question 11. This question is of vectors. The point A and B have position vectors I plus 2j minus 2k and 2I minus j plus k respectively. The line L has equation R is equal to I minus j plus 3k plus mu into 2I minus 3j plus 4k. This is the vector equation of the line L. Show that line L does not intersect the line passing through A and B. Position vectors of A and B points are given and the vector equation of the line L is given. We have to show that this line L does not intersect the line through passing through A and B. Line L is given, but we have to find the line passing through A and B. Then we will show that line L does not intersect the line AB. Now position vector of point A and B are given. We will write OA position vector. We will write position vector of A. OA is equal to I plus 2j minus 2k and OB position vector of B is equal to 2I minus j plus k. OA and OB shows the position vectors of A and B. And the equation of the line L is given. First we uh, write the equation of line L is given, but we have to show we have to write here the equation of line passing through A and B. This is suppose this point is A and this point is B. Line passing through A and B. We have to find the equation of this line AB. Let OA is equal to A vector A and OB is equal to B. We supposed. Now vector equation of line passing through 2 points will be R is equal to A plus lambda B minus A. So A and B are given. So line passing through A and B will be line AB will be R is equal to A is I plus 2j minus 2k I plus 2j minus 2k plus lambda into B minus A. This is B, this is A, B minus A we will subtract and write here. This will be after subtracting 2I minus I, that is I minus j minus 2j, this is minus 3j, k minus minus 2k, that is plus 3k. Now this is the vector equation of the line passing through A and B. This is line AB. Now equation of the line, vector equation of the line L is also given. line L, that is R is equal to I minus j plus 3k plus mu into 2I minus j, 2I minus 3j plus 4k. We have to show that these lines, line L and line AB do not intersect. So for this, first we will take the journal points on both lines. Journal point on line L and line AB. First, we are taking journal point on line L and line AB. Journal point, we will compare the coefficients of I, J and K. This small r is equal to, small r is the position vector of the journal point on the line. R is equal to xi plus yj plus zk. So we are comparing the coefficients of I, j and k to have a journal points on both lines. Journal point on line L, we will compare the coefficients of I, j and k. X is equal to 1 plus 2 mu. We are comparing the coefficients of I, j and k from here. On the left hand side, coefficient of I is x. On the right hand side, coefficient of I 1 plus 2 mu. In the same way, y coordinate of the journal point on line L will be minus 1 minus 3 mu. Z coordinate will be 3 plus 4 mu. These are the coordinates of journal point on line L. In the same way, we will take the journal point on line AB. So journal point on line AB, line passing through A and B, simply line AB you can say. Now again we are comparing the coefficients of I, J and K. This is the equation of vector equation of the line AB. Comparing the coefficients of I, J and K, we get x is equal to 1 plus lambda, y coordinate is 2 minus 3 lambda, z coordinate is minus 2 plus 3 lambda. These are the coordinates of journal point on line AB in terms of lambda. Now we will equate the corresponding coordinates of both the lines. Equating, we get x coordinate of line L is 1 plus 2 mu and x coordinate of line AB is 1 plus lambda. We are equating, so we get 1 plus 2 mu is equal to 1 plus lambda, and equating y coordinates of both the lines, 1 minus 1 minus 3 mu is equal to 2 minus 3 lambda. minus 1 minus 3 mu is equal to 2 minus 3 lambda. Let's say this is these are equations 1 and 2 for reference. Now from these two equations we will find the values of lambda and mu. So we are solving simultaneously. Now we will use here elimination method. We multiply this equation number 1 by 3 on both sides. This becomes equation 1 become 3 plus 6 mu is equal to 3 plus 3 lambda. Now we are adding equation number 2 and this equation number 2 we write here equation number 2. Equation number 2 is minus 1 minus 3 mu is equal to 2 minus 3 lambda. Adding, cancellation, simplifying we get 2 plus 3 mu is equal to 5. From here we get the value of mu is 1. Now putting this value of mu 1 in equation number 1, in any equation you can put this value of mu. We are putting this value of mu in equation number 1. Equation number 1 is 1 plus uh, 1 plus 2 mu is equal to 1 plus lambda. Putting the value of mu that is 1, we get 1 plus 2 is equal to 1 plus lambda. From here the value of lambda is equal to 2. We have found the values of mu and lambda. Now we are equating the z coordinates of both the lines. Z coordinates of both the lines. We get 3 plus 3 plus 4 mu is equal to minus 2 plus 3 lambda. Now putting the values of lambda and mu in this equation, we get 3 plus 4 into 1, right side minus 2 plus 3 into 2, left side is 4 and right side is left side is 7, left side 7, right side is 4. These values are not equal, so we can say that the lines do not intersect. Now these values are not equal, so we can say that lines do not intersect because all the coordinates of both the lines do not coincide. So 7 is not equal to 4. This shows that lines do not intersect. Next part of this question is part B. Find the position vector of the foot of perpendicular from A to L. A is a point and L is a line. Foot of perpendicular mean first I will clear that what is foot of perpendicular. Let this is a line and this is any point. Let this is point A and we draw a line from point A to this line. Now this point on the line is called the foot of perpendicular. As a whole, this line, let this point is P, say this point is P. Now AP as a whole is a perpendicular. AP is perpendicular on this line. So this point P is called the foot of perpendicular. This point P is called the foot of perpendicular. Now we have to find the position vector of this point P. We have to find the position vector of this point P from A to L. This line is L. We are making the diagram again. This is line L and this point is point P. Then this is this is point A. This is perpendicular on the line. This line is line L. This angle is 90. Let this point is P. Point P. This is a journal point on this line L. This is point A. Coordinate of point A are given. You can check this. This is the position vector of point A, but we will write here the coordinates of the point A, which are 1, 2, -2, and the equation of this vector equation of this line L is also given, and this point P is the journal point on the line L. We have to find the coordinates of this point P, which is the foot of perpendicular. This is a perpendicular. AP as a whole is perpendicular on this line and point P is the foot of perpendicular. We have to find the coordinate of this P. So first we take now first we say that the direction vector of line L and direction vector of AP. First we find direction vector of this line L and direction vector of this uh, line AP. Now the coordinates, since this point P is a journal point on the line, we will find the coordinates of this P. Coordinates of P. We have already found that journal point on line L is the last part. These are the coordinates of point P general, because P is a general point, its coordinates are, by comparing, we have already found these are the coordinates: x coordinate, y coordinate, and z coordinate. These are the coordinates of the general point on line L. So we can say that coordinates of P are: x coordinate 1 plus 2 mu, y coordinate is minus 1 minus 3 mu, z coordinate is 3 plus 4 mu. These are the coordinates of general point P in terms of mu. Now we have to find, first we have to find the value of mu, then putting here we get the coordinates of P, then we find the position vector of P. So clearly these two lines, this line L and this line AP, are perpendicular to each other. Then their dot product of the direction vector of line L and the direction vector of AP line, since these lines are perpendicular, then their dot product of their direction vector must be equal to 0. So direction vector of this line L is given. This is the direction vector line. This is the equation of the vector equation of the line L, and this vector is called the direction vector of the line L. Direction vector of the line L is 2I minus 3j plus 4k. So we can write here direction vector of line L, that is 2 minus 3 4. We can write the position vector in this form in column. Direction vector of AP. Now we will find the direction vector of this line AP. To find the direction vector of this line AP, we will subtract these 2 points. When we have to find the direction of any line, we subtract the coordinates of the both points on the line. So we are subtracting these points, we get the direction of this line AP. Subtracting direction vector of a line AP is equal to, we are subtracting 1 plus 2 mu minus 1 minus 1. We are subtracting these 2 points. 1 plus 2 mu minus 1 minus 1 minus 3 mu minus 2, 3 plus 4 mu plus 2. After simplifying, we get 2 mu minus 3. We will write here this. After simplifying, we get the direction vector of AP: 2 mu minus 3 mu minus 3, 4 mu plus 5. This is the direction vector of line AP. Now since AP and line L are perpendicular to each other, then their dot product of direction vector of line L and the direction vector of line AP, direction and dot product must be 0 because the lines are perpendicular. So we can find the dot product: 2 minus 3 4 dots 2 mu minus 3 mu minus 3, 4 mu plus 5. Dot product is equal to 0. Now multiplying 2 multiplied by 2 mu minus 3 will be multiplied by this. 4 is multiplied by this, and adding we get this is way to find the direct dot product. So 4 mu plus 9 mu plus 9 plus 16 mu plus 20 is equal to 0. From here, after calculating, from here we get the value of mu is equal to negative 1. We have found the value of mu. Now we will put this value of mu here. Now we can find this the coordinate of this point P. Putting now we will put a value of mu here. We get the coordinates of P are coordinates of P point P are putting the value of mu 1 plus 2 into minus 1. This is x coordinate, y coordinate minus 1 minus 3 into minus 1. This is y coordinate, and z coordinate is 3 plus 4 into minus 1. Simplifying we get point P minus 1 to negative 1. These are the coordinates of point P, that is the general point on the line L. Also this P is the foot of perpendicular. Foot of perpendicular is P. So we have to write this in position vector form. So position vector of this point P will be represented by OP, that is this is position vector minus I plus 2j minus k. This is the answer. Minus I plus 2j minus k. This is the position vector of the foot of perpendicular.